We often heard of integration. It is vital to many scientific areas, and most of the powerful tools are based on integration. So what is integration? Let's take an example to understand the concept of integration physically. Suppose there is a farmer who wants to buy a piece of land. In order to buy that piece of land, he needs to find the area of the land. The shape of the land is as shown in the figure, but note that the land does not have a perfect geometrical shape. Since there is no formula to calculate the area of such a shape, so how can he do it? The solution to his problem is to divide the land into many small approximate geometrical shaped pieces, for example, square, and then find the area of each of these small pieces. Further, sum up all individual small areas and obtain an approximate area of the land. This is nothing but integration. Thus, integration helps us to find the area of shapes whose sides are curved or when shapes are non-geometric. Do you know that differentiation and integration of a function are related? Let's first understand insight behind derivatives and integration. The original motivation for the derivative was the problem of defining tangent lines to the graphs of functions and calculating the slope of such lines. Further, integral calculus is motivated by the problem of defining and calculating the area of the region bounded by the graph of the functions. If a function f is differentiable in an interval I, its derivative f dash exists at each point of I, then a natural question arises that given f dash at each point of I, can we determine the function? Well, the answer is yes, we can determine the function y with the help of integration. For example, a derivative dy by dx equals to cos x. We know that it is the derivative of the function y equals to sin x. In fact, the function y obtained from its derivative is known as antiderivative. Thus, the functions that could possibly have given function as a derivative are called antiderivatives or primitive of the function. Well, the concept of integration is in fact finding the antiderivatives. Moreover, it is the reverse of the differentiation. Further, the formula that gives all these antiderivatives is called the indefinite integral of the function. Such problem arises in many practical situations. For instance, if we know the instantaneous velocity of an object at any instant, then there arises a natural question, that is, can we determine the position of the object at any instant? In addition, there are several practical and theoretical situations where the process of integration is involved. The development of integral calculus arises out of the efforts of solving the problems of the following types. First, in the problem of finding a function whenever its derivative is given. Like if dy by dx is equal to cos x, then y is equal to sin x. Second, in the problem of finding the area bounded by the graph of a function under certain conditions.